Hey guys, welcome back. In the previous videos, we learned about fuzzy sets and their cardinalities, unions and intersections of fuzzy sets. So today in this video, we are going to learn what an algebraic sum is and what the bounded sum of two fuzzy sets are. Alright, so let's go. So in algebraic or probabilistic sum, we calculate it by taking all the membership values and we sum it all together with set A and set B. Similarly, we find the multiplication of the two fuzzy sets, and when we have the resultant value, we subtract it from each other. So that's how we calculate the probabilistic sum according to the mathematical definition. Likewise, for bounded sum, we find this method right here, minimum method. So what it means is that it adds two values for membership values in fuzzy set A and fuzzy set B. But if the sum exceeds 1, then it just stops at 1. So this is basically the limit right here. So say supposing it had the number 5 instead of 1, that would mean the sum should not exceed more than 5. All right, so moving on to the program, as you would have seen my previous videos, which I would highly recommend before you come to this particular video and check them out and see that I had explained in the first and second segments where we call the method create fuzzy dictionary. And how we do that is we create a object which is of type algebraic bounded sum, and we use that object to call that dictionary, which is encapsulated by the parent class algebraic bounded sum. Now right here, I also created and initialized the fuzzy dictionary inside the default constructor. Now in these three methods I had shown before, the first method, that is create fuzzy dictionary, I use a loop, two loops, one to check the elements if it exists. If it doesn't, it creates a new element, and like that we go on, and membership values where it has to fulfill this condition, and we keep entering each membership value and updating the fuzzy dictionary for that particular element. All right, so moving on to the main portion of this program, which is the method algebraic sum right here, and bounded sum as well. So in this algebraic sum, we have the type hint, which is algebraic bounded sum given in double quotes, which is actually the class. So this is a type hint, and it is a string based forward reference. And this method algebraic sum returns a dictionary, which is result. So in this line, we have two sets, fuzzy dictionary, and this is for set A, and other dot fuzzy dictionary dot keys, which has contains the keys of set B. We take that, convert the keys of both fuzzy sets into the Python sets, and perform the union operation. Now here we could have even done this dot union. Either way, it's the same thing, right? So we in this way we calculate all the keys and we put them into one set. Now on doing this, the resultant set that we get, as I had shown you in the previous video, that when I compute it and get the result, it is in an unorderly fashion. It is because that we have taken the set right here. We are changing the dictionary to a set. So a set is not in an unordered, is in an unordered fashion. That is the reason why from the dictionary, which is ordered, we convert it to a set, so remains unordered. And when we convert the set back into a dictionary, which is the resultant set, we get a dictionary which is unordered. So moving on, right here, this value a and variable a and variable b, it takes the values using the get method, which takes the first parameter as key. That means it corresponds to that particular key, and if the value for that key we get 0, then if we don't get a value for that key, then we return the value 0 for that variable a. Similarly, we do that for the second set and we put them into variable b. Now according to the mathematical calculation, we follow the same way right here. We multiply them, we add them, and we subtract both from each other, and the value that we get, we insert that value or assign that value to the result dictionary, corresponding to that key. Similarly, in this bounded sum, we have the same functionalities right here, but in this line number 53, it enforces the fundamental constraint of fuzzy sets that membership values must lie between the interval 0 and 1. That means the sum right here, a and a plus b, must be between 0 to 1. If it exceeds 1, we'll still give it as 1. That is the exceed limit. So the computed fuzzy set is returned as a dictionary right here, where each element is mapped into a bounded membership value. So basically, before I compute or compile and interpret this program, I would just like to mention that the bounded sum models a constraint, or the bounded sum models a constrained union operation where overlapping memberships are combined but strictly limited to 1 in this case, making it suitable for systems requiring normalized outputs. Compared to algebraic sum, bounded sum is computationally simpler and enforces simple and hard cap. So hard cap means what? It means the result is never allowed to exceed 1. It cuts off at the maximum limit. Whereas algebraic sum provides a smoother probabilistic combination, right? So on executing this, we enter the number of elements giving, say, 3, the first element as a, and give it a value of 0.8, b as 1, c as 0.4. For set b, we give the same element 0.7, say. For b, we give, say, it's 0.9, and c we give 2. So we can't give an invalid value, as I had mentioned earlier. So we have to give it between the range 0 and 1, and right here we give it as 0.8. So the algebraic sum, according to what we have mathematically calculated here, according to this calculation, we are taking the sum of 0.8 and 0.7 and multiplied them together and found the subtraction, the difference between those two resultant values rather. Similarly, the bounded sum is calculated in that manner. I'm pretty sure that the bounded sum that we have calculated here, that is the sum of each, exceeds 1. So it definitely exceeded 1. That is the reason why all the values we see here are 1. So that's it. If you like this video, please do, I do recommend check the previous videos. It's even better. And the next few videos that is about to come, I'll be posting more on shallow and deep copy. So stay tuned.